Okay, good morning. Welcome to the second annual Discovery Farms Multi-State webinar. We really appreciate you choosing to spend time with us today. Over the course of the morning, we are featuring the work of Discovery Farms programs in Wisconsin, Minnesota, Arkansas, and Vermont. My name is Amber Raditz. I'll be your moderator for the day. I'm the Agriculture Water Quality Program Manager at the UW-Madison Division of Extension. The success of the Discovery Farms program and demand for agriculture water quality information has driven Wisconsin to create a new program area around ag and water quality and has increased capacity to come along with it. This multi-state effort featured today is in place to provide farmers, farm advisors, and interested stakeholders with credible water quality research information. I've got a few housekeeping things before we get started. First, we really encourage questions and discussions from you. That makes a much more exciting webinar experience for all of us, hosts and panelists included. So please put your content-related questions in the Q&A box, which can be found at the bottom of your screen. Please put any questions related to logistics, like if you have technology issues, agenda questions, or other logistics into that chat box at the bottom, and we can address those separately from the Q&A that's for our speakers. Secondly, if you would like to receive CCA credits for your time here today, we will show the QR code at the end of the session for you in order for you to get all three of those soil and water credits that are available for today's webinar. At that time, you can scan the code from your phone to register for credits or put your CCA number in the chat and we can register them for you. Each state will have 40 minutes of presentation time, including answering questions. So each speaker is going to speak for about a half an hour and then have some time for questions at the end of their talk. There might be some time at the end of the full session for questions that could be directed at multiple speakers, but we really do encourage you to ask questions right away during that speaker time and also use the Q&A feature to actually vote for questions that you resonate with as well. Okay, I'll provide you with a brief background on the Discovery Farms program, and then we'll kick off with the other speakers. So Discovery Farms was first established in Wisconsin in 2000. It was formed in response to a call from the agriculture and environmental communities for enhanced on-farm research in the area of water quality. Farmers volunteered to host water quality monitoring stations in Wisconsin to better understand the dynamics of runoff timing, the impact of agricultural management, and the influence of weather. Over the years, programs have been added in Arkansas, Minnesota, Washington, and Vermont. Representatives from each state pursued the determination of Discovery Farms, which is a registered trademark, because of the positive response to the work of the program from farmers, farm advisors, agency partners, and water quality stakeholders. Each Discovery Farms program has to include the three pillars of Discovery Farms, including farmer leadership, credible water quality research, and communication of results. For the Wisconsin Discovery Farms program, farmer leadership occurs through our steering committee made up of representatives from agricultural and environmental groups throughout the state and from the farmer participants themselves that play a key role in communication of results and articulating the value of on-farm research to their state and local communities. Before we get started with the Wisconsin speakers, I do just want to take a brief moment to acknowledge somebody who's not here with us today and remember Eric Cooley. Eric worked with Discovery Farms Wisconsin for 18 years and was really a cornerstone of the work and passion behind Discovery Farms' on-farm monitoring efforts and service to Wisconsin farmers with this research data. Eric passed away in February after a hard-fought battle with pancreatic cancer, and we continue to miss him every day. Okay, so let's get started with our speakers for today. Our first speaker of the day is Lindsay Hartfield. Lindsay is the Research Program Manager for Discovery Farms in Wisconsin. Lindsay started with Discovery Farms in January after finishing her PhD at Iowa State University. Today, Lindsay's talk is titled Building a Network of Conservation Practices. Can we improve our water quality impact? Welcome, Lindsay.
Okay, just a second. Are you seeing the presentation mode?
Yep, that looks good.
Okay, thank you. All right, thank you, Amber, for the introduction. I will jump right into things and get started. Like she said, I'll be talking about building a network of conservation practices to see if we can improve our water quality impact. And like Amber said, a lot of this work was done by Eric Cooley, who's no longer with us. So I want to acknowledge that I'm pretty new in this role. And so this work is really a result of the hard work that Eric put into this research. So as Amber explained, the Wisconsin Discovery Farms program began in 2001 with a goal of being able to get research onto real working farms in Wisconsin. Prior to this, the research was really primarily being conducted at universities or on small research stations or plots. And so there was an interest by farmers to get this research onto their real full-scale working farms. And so as part of this, the Discovery Farms program has really focused on incorporating that farmer leadership into our work by providing the farmers a seat at the table, especially during these state level water quality conversations. So in this process, we have been able to support farmers in their efforts to implement practices that work in their area locally, and also to be able to verify those practices to see how well they are working. So in Wisconsin, our major water quality conversations are centered around soil, phosphorus, and nitrogen losses. With Wisconsin's dairy industry, there are large quantities of manure to be applied each year. And so locally, this has caused water quality concerns due to algae blooms linked to those phosphorus losses. And those are associated also with the soil loss. But we also have concerns with nitrogen losses in our state, especially in sandier regions of Wisconsin or areas that have shallow groundwater, where our nitrogen in the form of nitrate can be leached into our groundwater and cause human health concerns. So while initially 3 major water quality challenges doesn't sound so bad, the story is a bit more complicated than just that. So part of the complications with that is that we need to understand how those losses are occurring, when they occur, and what form they are occurring in, so that we can address these challenges. So to help answer these questions, we've partnered in Wisconsin with USGS, using the system shown on the slide here to be able to document the surface runoff leaving the edges of fields. And this partnership has really allowed us to collect credible on-farm research for over 20 years now. So when we consider the when and what form that these pollutants and the losses are happening, there's really several factors to consider, and these have both soil physical and chemical properties that we need to consider. So in terms of soil loss, it's important for us to understand when these losses are occurring in terms of the time of year, and part of that goes with what kind of soil conditions. So we classify these as, is the soil loss happening during frozen or non-frozen soil conditions? And when we say frozen, we mean at any depth is there still frost in the soil, because then that water can't infiltrate into the soil profile. So when we see soils leaving in our runoff, is it happening when there's still frost in the soil or not? Then in terms of phosphorus losses, we can further break that down into particulate phosphorus or dissolved phosphorus losses. And when we look at nitrogen, this can also further be broken down into organic nitrogen, nitrate, or ammonia losses. So 3 big challenges can be broken down into several more parameters. So for us to be able to address these soil, phosphorus, and nitrogen losses, we need to first understand when the losses are occurring. So here I'm showing the average amounts of surface runoff by month at our Discovery Farm sites since 2001. So looking at this graph, we can see that March tends to be what we call like the month for runoff. So most of our runoff is happening in March, and it's largely a factor of snow melt on those mostly frozen soils where the water cannot infiltrate into the soil profile. June is the next month with the most runoff on average, and that's really a result of larger storm events happening on fields where the crops are just getting to be established, and they can't take up too much water. So when we look at this breakdown of when the surface runoff happens, roughly half of the runoff occurs during frozen soil conditions, and the other half happens during non-frozen soil conditions. But knowing when we can see the surface runoff happen can help us to control what is in the surface runoff in terms of our soil and nutrient losses. So then looking historically at our soil loss by month, we can see that May and June tend to be the most critical months in terms of soil loss. That's despite March being the month that had the most runoff. So again, March, we typically have frozen soils here in Wisconsin, and so most of that soil can't really be moving during that time period. But in May and June, that's when we have really the most vulnerable soil conditions. We can have a lot of soils that maybe they had recently been tilled, or a new crop was recently planted, cover crops were terminated, and this can leave that soil exposed and more bare and more vulnerable then to runoff. And then just overall, if we can get the soil loss then that we're seeing in May and June under control, this can go a long ways for us in terms of getting particulate phosphorus under control. And so the reasoning for that is that when we talk about phosphorus, there's kind of three categories that we break it down into. We break it down into total phosphorus loss, particulate phosphorus, and dissolved phosphorus losses. And this really has both physical and chemical soil considerations with it. So in terms of particulate phosphorus, this is the loss that is in the form that's attached to the soil particles. And so when we have soil erosion, soil losses from the field, we will also see particulate phosphorus losses. So if we can physically control that soil loss, then this can help to control particulate phosphorus losses. In terms of dissolved phosphorus, this is the phosphorus that's dissolved in the water, and so it leaves the field in the water, whether that be in surface runoff or with tile drainage. This is where considering the soil chemistry comes into play. When we have higher phosphorus levels in the soil, the more likely we are to have high dissolved phosphorus leaving the field. And so it's particulate phosphorus and dissolved phosphorus together that makes up our total phosphorus losses. So when we look at total phosphorus losses by month across our what we've seen at the Wisconsin Discovery Farm sites, we can see there's kind of two time periods of concern. February, March is one time period, and then May, June, July is another period with elevated phosphorus losses. So in late winter and early spring, we again have those frozen soils that don't allow that snow melt to infiltrate into the soil. But that snow melt or spring rainfall that might happen, it does interact with the soil surface. So whether we have high soil test phosphorus at the surface of the soil, or maybe we had a manure application that wasn't incorporated into the soil, that interaction with the surface of the soil, we can see elevated dissolved phosphorus losses leaving our field, and that's represented by the lighter purplish pink color on the graph. So looking at that time period, we can see in terms of the percentage of losses, that time period contributes about 40% of our annual total phosphorus losses, but it makes up 70% of the dissolved phosphorus losses for the year. Later in the year, in May, June, July, that time period, that's when we saw some elevated soil losses on the previous slide. And due to that soil loss and a new crop being established during that time period, that's when we can have higher soil loss, and we can see higher particulate phosphorus loss represented by that darker purple color. And in that time period, in terms of how much of that makes up our annual phosphorus loss, May, June, July makes up roughly 45% of our annual phosphorus losses, but 70% of our particulate phosphorus losses. So for us, understanding the type of phosphorus loss and the timing of those losses, it helps us to make better decisions on how to best manage our agricultural systems to reduce the phosphorus losses from happening. So we've identified the times of the greatest risk of runoff, soil loss, and phosphorus loss in Wisconsin. But now how can we prevent those losses from happening? So 20 years ago, when our Discovery Farms program was just beginning, the focus for us was really centered around soil loss and getting that particulate phosphorus under control. We've since learned a lot about this and have some tools to share with you today to help us address these water quality challenges. And I want to emphasize, though, that unfortunately, we don't have a one-fix solution to our water quality concerns. And instead, it will require us to use several tools in our toolbox to address the water quality concerns. So diving into the toolbox, our conservation toolbox, our first tool to addressing our agriculture water quality is the grassed waterway. This is a conservation practice that I'm sure many of you are very familiar with. It's been used now for decades, but it really still proves to be an essential conservation practice for us to consider and use. Grass waterways are used to protect concentrated flow pathways in the field where gullies are or would form without the grass waterway being present. Without the protection from these waterways, we've seen huge amounts of soil loss and in turn phosphorus losses because of that erosion happening in the field. So on the slide, I'm showing 3 pictures showing various levels of grass waterway establishment. So looking from left to right on your slide, you can see a greater establishment of a grass waterway, and with that rightmost image showing a fully established waterway. So now getting into some data to support this, here I'm showing soil loss at 2 sites that we are currently monitoring. And the first 2 years of data were prior to installing and repairing a waterway. So the site labeled KD1, that is a site that did not have a waterway installed, and the second site, KD2, that one is a field that had a waterway installed, but it was in need of repair and reshaping. So the first 2 years, that was before installation or repair of the waterways. And in those first 2 years, we saw really high soil loss in those fields. I want to note that there is a break in the graph. So those losses are even a little bit more extreme than what the graph portrays. But after adding in a waterway or repairing the waterway, we did see significant reduction of soil loss at both of the sites. So these waterways do work to lower the soil loss within the field. So how does that then translate to phosphorus losses? In general, our total phosphorus losses have declined. Before, you can see there was elevated, especially at that KD1 site. And then after, we have generally lower phosphorus losses. I will note that the KD1 site last year in field year 22, that one had higher dissolved phosphorus losses. That was a result of a late manure application in November. That was pretty close in time to a runoff event. But overall, these grass waterways, they did significantly reduce the soil losses. And then in terms of phosphorus losses, we haven't ran the statistics on it. But we will in the future, and we are continuing to monitor these sites, so we'll be able to add some more data behind this before and after comparison of the waterways and their impact on water quality. So grass waterways are a great starting point for us to control our soil and phosphorus losses from the field. Without their presence, we did see on that previous 2 previous slides ago that there was huge amounts of soil loss. They were up as high as about 50,000 pounds per acre per year. So those are huge amounts of soil loss. And we could see that the waterway helped to get that back under control. So while the grass waterway helps us to lower the soil and phosphorus losses leaving the field, they don't actually prevent the soil and phosphorus losses happening within the field from reaching the waterways. So the next step for us to consider in our conservation toolbox is to stack practices on top of the grass waterway to provide in-field soil protection as well. So some of our options that we could include in the field are using practices like no-till or reduced tillage, cover crops, including perennial crops in your rotation, and practicing residue management. All of these practices can provide soil protection during vulnerable periods of soil loss in the late winter through early spring, when our soils are at their most vulnerable point. I would also argue that stacking these practices with your waterways, these could also potentially extend the life of the waterway by lowering the overall amount of sediment entering the waterway. And by doing so, that could potentially extend the time before your waterway may need that repair and reshaping to happen. So again, digging into some data now. I started this presentation by highlighting that water quality concerns within Wisconsin are complicated. So far, I think the story has been pretty straightforward. Get your soil loss under control. This will help get your phosphorus under control. Here's where the story gets a little bit more complicated and complex. So while controlling soil loss is a starting place for managing phosphorus, it's not the ending place. And we still have that dissolved phosphorus to talk about and to consider and manage for. So here I'm showcasing results of tilled versus no-tilled edge of field monitoring from both the Wisconsin and Minnesota Discovery Farms programs. This slide is getting a little outdated, a little dated. It could be updated, but it draws the point. And this is a point that we're still seeing even if we update the data. So starting on the left with annual soil loss, we see that fields that have tillage versus no tillage have roughly 4 times the soil loss compared to those fields with no tillage. So no-till obviously is very great at controlling for soil loss, and in turn that will result in lower particulate phosphorus loss. Now, when we look at the middle graph here, we see similar levels of total phosphorus losses in tilled versus no-tilled fields. So total phosphorus though looks pretty comparable between the two. So that leaves dissolved phosphorus as the reason that no-till has the same total phosphorus loss as a tilled system. So why is that? In our no-till systems, the soil is undisturbed, more protected, so less particulate phosphorus loss, but that means our nutrient applications are going to be applied at the surface of the soil. And so we've seen this result in higher soil test phosphorus levels at the soil surface. We get this stratified layer of higher phosphorus levels. And so we can see higher dissolved phosphorus losses in runoff from these no-till fields. 20 years ago, when we started our work here, dissolved phosphorus losses wasn't really something we had considered or fully understood. Today, we're getting a better understanding of dissolved phosphorus losses and the drivers for those losses, but this really is our most pressing challenge. We're working to figure out how we can control these losses from occurring. And so I want to emphasize that while no-till fields are seeing higher dissolved phosphorus losses, there are so many other benefits from no-till fields. Getting that soil loss under control is the first step in managing for phosphorus losses. So I'm not going against no-till. It's a great practice and one to definitely consider. So instead, I want to look for ways that we can maintain the low soil disturbance of no-till while also lowering those dissolved phosphorus losses. So how can we do that? So with that thought in mind, again, the main driver of those dissolved phosphorus losses in the no-till fields is that they have this stratified higher phosphorus layer at the soil surface because we're not incorporating those nutrients below the soil. So if we can balance the nutrient incorporation with minimal soil disturbance, this is really how we are going to best manage our phosphorus losses from a particulate and dissolved phosphorus perspective. Showing the data to support this, this slide is demonstrating a field with manure, low disturbance manure incorporation, which is the purple bar or the label JF5. And that site had, on average, about 50% lower annual dissolved phosphorus losses compared to surface applied manure to a no-till and pasture system. Those are the JF2 and JF4 sites. This represents an area that we can continue to look at into the future with research to monitor the impact of no-till or reduced tillage, and pairing that with a low disturbance nutrient application method to see how that continues to impact dissolved phosphorus and particulate phosphorus losses. So incorporation is an important part of reducing overall phosphorus impacts, but I want to emphasize again, this only can be done if we are not increasing those soil losses. Getting your soil loss under control again is the first step. So as a reminder, there's a balance between particulate and dissolved phosphorus. Part of that balance is balancing that nutrient incorporation while also balancing for soil loss. So when we incorporate our nutrients, there's a risk of particulate phosphorus losses. When we don't incorporate them, then we have that risk of dissolved phosphorus losses. So if we can balance between the two, incorporating our nutrients while maintaining low soil disturbance, we can see the greatest reduction in total phosphorus losses. Underlying factors that will also play a role in controlling these phosphorus losses are factors like weather. So how soon after you apply nutrients, was there a runoff event that will have an impact? Timing of runoff will also influence what type of losses and magnitude of losses we're seeing. So with dissolved phosphorus, we'll see more of those losses under frozen soil conditions. Particulate phosphorus when the soils aren't frozen, and we can have soil erosion and losses. But there's another factor that also plays into these losses, and that's soil test phosphorus levels. So this can be a driver of how much phosphorus losses we can see or expect from a field. So while we do have some factors like the weather or its timing that are out of our control, to best balance our particulate phosphorus and dissolved phosphorus losses, we can focus on the factors that we can control, like how we're applying our nutrients, when we apply them, what kind of soil disturbance level we have, and also managing for our soil test phosphorus levels. So part of balancing between that soil protection and nutrient incorporation can come with stacking of our conservation practices with the 4 R's of nutrient management. And these are applying our nutrients at the right sources. So looking at the nutrients that your crop actually needs and comparing that to what's already in the soil. Applying nutrients at the right rate. So providing nutrients at a rate that your crop is expected to uptake and need to meet reasonable yield goals. Applying your nutrients at the right time. So trying to match up when you're applying nutrients to when those crops are going to use them. And then applying them in the right place. So in the right field, and within that field, trying to incorporate them if we can with the minimal soil disturbance. So looking at how timing impacts our losses, this slide's highlighting that. The graph is representing the relationship between dissolved phosphorus losses on the y-axis and total phosphorus losses on the x-axis. And this is looking at how manure application influences those losses. So here the purple filled in circles represent sites where there was no manure application made in the winter. The squares, open squares, represent an early winter manure application between November to January. And the open circles then represent a late winter manure application. And from this graph, we can see a really pretty direct linear relationship between dissolved phosphorus and total phosphorus losses, almost a 1-to-1 relationship between the two. And we also see when we look at where those higher losses are occurring, they're really coming from that late winter manure application, those open circles. So kind of pulling all the points together about soil and phosphorus losses, I think this really does demonstrate the need to stack the practices together with nutrient management and in-field protection to see the biggest water quality benefits. So now you might be asking yourself, what about nitrogen? You said that was your third big challenge in Wisconsin. So I highlighted that the soil and phosphorus losses. For nitrogen, similar practices that we use to control for that soil loss and particulate phosphorus loss will help us with our organic nitrogen losses. Our organic nitrogen is also a part of the soil particles. So if we can stop the soil movement, will help to keep organic nitrogen in place. Other forms of nitrogen, like nitrate, are more mobile in the water. And I do know that Tim's presentation coming up next will be highlighting tile drainage. And so I'm sure he's going to cover nitrate quite a bit in his presentation. So I'm not going to steal his thunder and I'll leave that discussion to him. But I do want to highlight that a lot of the concern with this nitrate moving is associated with that mismatch between when the nutrients are applied or are available in that soil and when the crops are going to use the nutrients. So practices that can help to protect the soil while also lowering nitrate losses. Those include cover crops, which are shown on both of these images here. And the left one is showing the concept of planting green. So this is planting directly into a cover crop. And so these are strategies that do show promise to address soil nitrogen and phosphorus losses together. By planting green, there's a living crop using excess nitrogen, taking it up, protecting the soil. So it does show promise to hit all three together. In Wisconsin, when we talk about nitrogen, our greatest concern comes with nitrate entering our groundwater. So I do want to highlight a current project that we have where we're investigating nitrogen losses from agricultural fields below the crop root zone. So to do this, we're using equilibrium tension lysimeters. So one of those is shown on the upper left side of the screen. And this is going to be used to try to understand how much water and nitrogen are being transported below that crop root zone, what's leaching below and away from those crops. So you can see what the lysimeter looks like in the upper left image, and then below that is showing one of those lysimeters being installed in the field. And to the right of that is showing kind of a schematic of what our whole monitoring setup for these lysimeters looks like. There's a control box as part of these lysimeters, and one control box we use to control two of those pan lysimeters in the soil, and they collect the water that gets below the crop root zone and whatever's in that water, and then we will collect those samples and how much water ended up in the lysimeter, and we can get the losses from the field. So we installed 8 of these lysimeters about 1.5 years ago now. So at this point, we don't have data to share yet, but we are hoping to do a kind of control and treatment study to understand how different practices or management practices can impact the nitrogen leaching to the groundwater. And so hopefully in a few years, we'll have more to share about this project. We have more of these lysimeters planned to be installed in the near future. So hopefully we'll have more to share with you in years to come. Now, just to pull all this information together, I want to pull out some key takeaways for you to consider. So the first key takeaway from today is that protection of concentrated flow pathways is truly the first step to controlling your soil and phosphorus losses from leaving your field. And then the next step is to stack practices to provide in-field soil protection. So some options would be no or reduced tillage or using cover crops to just try to keep that soil in place in the field and prevent it from leaving the field in the first place. And then the next step is to remember that these conservation practices can be stacked with nutrient best management practices to allow us to see the best water quality leaving our field. So while it can be frustrating that there isn't a quick one fixed practice to our water quality challenges, it's important to remember that your farming system, as well as the climate, are continuously evolving. And so as a result, so will our water quality challenges. And so will our best management practices to address those water quality challenges. So to meet those ever-evolving challenges, it's important to build a network of conservation practices that work for your system and that can make your system, as a result, more sustainable and resilient to the ever-changing world around it. So with that, I would like to leave you with a question to ponder and consider over the next few days. And that question is, what tools are in your conservation toolbox that you could consider adding? So what could you add to your system to make it more sustainable and resilient to the changing world around your system? So with that, I'd like to thank you all for listening in today. And if there's any questions, I'm happy to answer those now. I also have my contact information on the slide if you'd rather reach out directly as well. So thank you.
Awesome. Thanks, Lindsay, for that great presentation and distilling down a lot of information in a short amount of time. Nice work. So there were a couple of questions that we went ahead and answered in the chat, in the Q&A box. So make sure that you go there and check those questions out. There's some typed answers And then for you, Lindsay, there was a question that just came in. Does the lysimeter system collect and store samples for later analysis or use a nitrate sensor reported to the data logger?
Our lysimeters, it collects the water, and we will collect that roughly bi-weekly. In the winter, we might go longer than that just because there's not as much water flow, but it does not have a nitrate sensor. We go out and collect the sample about roughly bi-weekly and then analyze it in the lab.
Great, thank you. And then of the ones that were answered, there was one question just about like rain at different times of year and how that influences nutrient runoff. So I typed an answer in there about kind of what triggers runoff, but do you just want to briefly touch again on like what influences the amount of nutrients that might be in runoff during a different part of the year, a given part of the year?
Yeah. So if we have like a nutrient application, like a manure application or fertilizer application that's close to a runoff event, I'd say like within a few weeks of that, there's a greater risk of having those nutrients be lost in the runoff. So that's where the incorporating nutrients into the soil lowers that risk. If it's on the surface, obviously, if we have runoff, there's a greater risk then of those nutrients being moved. So really kind of balancing the timing of nutrient application with the greatest risk of runoff is the key to improving that water quality.
A balancing act, like you said.
Yes.
Okay, great. Well, thanks again, Lindsay, for that. I see there's some accolades in the chat for you about that. So obviously people resonated with what you presented. So we'll go ahead and continue on for now. If you do have other questions that might be for Lindsay as you watch the other presentations, you could go ahead and note that in your question as you put it in the Q&A, and either Lindsay could type the answer or we can address it at the end when we have some time. So our next speaker will be from the Discovery Farms Minnesota program. We have Tim Raditz with us. Tim works as the Discovery Farms Minnesota coordinator. His talk today is titled More Than a Pipe, and he will talk about the agricultural tile drainage work that's been completed by the Minnesota Discovery Farms program. So go ahead, Tim.
Thank you, Amber. Can you see everything okay?
Yep, looks good.
Right. Well, I'm glad that Lindsay didn't steal my thunder. She did a great job talking about surface water issues, and I would echo if I were to talk about those things with what we see in Minnesota, it's the same story, and so that's exciting. I'm going to talk a little bit more on tile drainage than surface water runoff today, so we planned that out really well. So just to touch on things Lindsay already touched on, but we're a farmer-led water quality research and educational program. We do work on privately owned farms throughout Minnesota, and we focus on farmer leadership and water quality discussions, doing credible edge of field research, and then communicating those results. An important part of what we do is collecting data from the edge of field 365 days a year. So as Lindsay said, snow and snow melt is a very important section of our water budget in Minnesota. So being able to monitor and collect data during that snow and snow melt season is essential for getting a complete picture of water quality metrics from edge of fields in Minnesota. And our program is really built on partnerships. Farmers are key, of course. They sit on our steering committee, decide which projects we take on, provide input on what research needs are. And also our farmers that participate in the program are essential in terms of their knowledge of their local landscapes and weather conditions allows us to really understand what's going on in those fields. We also have a great partner in the Minnesota Department of Agriculture in terms of collecting our water data. So they're some of the leaders in their field in terms of collecting this edge of field, surface runoff, or tile data. They're the ones that make sure everything is operating correctly, and install all of our equipment and provide us with a high quality, unbiased data source that we can use for education and outreach. Another big partnership that our program depends on is our local partners, either through local soil and water conservation districts or watershed districts. These are the people that actually go out and collect the samples and maintain the sites. Minnesota is a very big state, so without their local local location, I guess, we could not get to everywhere to collect this data and get a data set that really does a good job of creating a picture for the whole of Minnesota. So I just wanted to start out today by talking a little bit about what different types of agriculture we have in Minnesota. I know there's some people from out of state and as far away as Vermont, so probably not very familiar with what we do in Minnesota in terms of what we grow and what we produce. But here's a chart from the Minnesota Department of Agriculture showing the different agricultural products that we produce in Minnesota. So very diverse state in terms of the agriculture, a lot of different things going on. But corn and soybean would be our two highest products, followed by hogs, and then cattle and dairy, poultry, wheat, and then sugar beets. And along with a bunch of other things that are being produced. So quite a diverse agricultural landscape, which makes it really interesting to work in Minnesota because you get to work on so many different farms and with so many different farmers. So really appreciate that aspect of the state. In terms of our water quality challenges in our landscape, I think a lot of it is depending on our landscape and climate. So Minnesota being in the north, a lot of our landscape is we can give thanks to the glaciers for in terms of where our soils came from and our topography. But this is just a map showing different paramaterials of soils in Minnesota, and most everything is driven by glacial processes, whether it would be glacial till or glacial outwash plains or lacustrine sediments from glacial lakes. So most of Minnesota agriculture takes place in the northwest, sweeping down through the central of Minnesota and then to the southeast and moving all the way to the southwest. So the only real place where we don't have a lot of glacial activity impacting our soils would be the driftless region in southeast Minnesota, and this is where we get more hills. That area moves into Wisconsin and Iowa and Illinois, so it's a very defined, interesting area defined by a lot of coulees and in valleys and ridge tops. But for the rest of Minnesota, more dealing with that glacial till, glacial outwash, and lacustrine sediment. This middle map shows the elevation of Minnesota, so kind of a relief map to kind of give you a picture of what we're dealing with. A lot of where our agriculture is in Minnesota is in this on the northwest side, moving through the center and down to the southern part of Minnesota. We're dealing with a lot of flat slopes, flat and low-lying areas, so not a lot of relief. We get more relief in the southeastern part, which is a area unique to Minnesota. But for the most part, we're dealing with low relief, lower elevation type soils. And if we combine that with our precipitation, we have anywhere from 36 to 21 inches of rain on an annual average. So during the year in Minnesota, you know, there's going to be times during the year in Minnesota where we're going to have excess precipitation. And as our climate changes and we get more precipitation in shorter time periods, or it's more focused on certain times of the year, this excess precipitation becomes a bigger challenge. So that's the climate we live in. We have excess precipitation, not during all times of the year, but certainly during throughout a year. There'll be times where excess precipitation is a challenge, and low slopes. So that can lead to a landscape that looks like this. It's sort of a classic prairie pothole type situation where we have some internally drained areas, but we just have a lot of water with not a lot of places to go with natural drainage. So what do we do for that in terms of agricultural production? We've done a lot of tile drainage to have productive agricultural soils in Minnesota. And here's a map. It's an outdated map from 1992, but showing the percent of county soils or land with subsurface tile drainage. Just making a point that subsurface tile drainage is a big part of our Minnesota agricultural landscape because of our excess precipitation and because of our landscapes and soils. So when we're talking about tile drainage, we have many benefits from this. We have better plant establishment, growth, and yield, better timeliness of field operations, and also reduce surface runoff and soil erosion. So the figure on the right is a good example. By installing that subsurface tile drainage, we can lower that water table, have deeper root growth, better, healthier plants to utilize the nutrients that we're putting out there, but also in turn creating sort of a sponge effect where we're going to have some ability to infiltrate more rainfall that would come during certain times of the year, and therefore reducing that surface water runoff and soil erosion that Lindsay had touched on in our previous presentation. We also have potential water quality challenges with tile drainage. So it provides a conduit for water-soluble nutrients, especially nitrate, and I'll talk on that later. So what we focus in on a lot with our education and outreach is talking about good nutrient management practices, specifically nitrogen management practices. If we have tile drainage, we need to make sure we're managing our nitrogen correctly to reduce losses through that tile system. And when we're managing our nitrogen, we're talking about using the right source, using the right rates for the crops you're planting, applying them at the right time, and putting them in the right place. So that 4R concept is very important to us and something we talk about a lot. When we do talk about tile drainage, I think there's some misconception out there in terms of what sort of water we're removing with tile drainage out of the soil profile. I get a lot of comments about, boy, you're just removing all that water and creating drought conditions. That is not necessarily the case. There's only a certain portion of soil water that can be removed with tile drainage. And if you think of your soils as about half pore space and half solids, that pore space can either be filled with air or water. And when it's completely filled with water, that's what we call saturation, and that's where water moves freely in the soil profile with gravity, so gravitational water. And that's that water that our tile drainage can remove. Only water that moves freely with gravity through the soil profile. A lot of the water is, as shown in this middle picture, held in that soil matrix, and there's some pressure on that. So the tile, it can't go in and provide a suction to draw that water out. So all that water is not removable by tile drainage. And the amount of gravitational water or field capacity in your soil profile is generally determined by your soil type. So depending on if you have sands, loams, silty clay loams, clays, anything through the spectrum is really going to define what sort of drainage potential your site has. And this is just a graph showing the different amounts of inches of water per foot of Gravitational water would be in this gray bar, followed by field capacity, and down to wilting point, and then this red portion of the soil water is unavailable for plants or drainage to remove. But this gray bar is the section of that tile drainage is really going to impact, and that's the part that we're looking at. So if we're looking at data we've collected in Minnesota, and we've been collecting edge of fields, surface runoff, and tile drainage data since 2007 or 2008. So for a number of years, we have a lot of site years of data, and a number of those sites we've collected surface runoff and tile drainage at the same spot. So monitoring from the same field, same area, collecting at the same spot. So we really get a good handle on the differences between surface water runoff and tile drainage when we're looking at different water quality constituents. Excuse me. So if we're looking at runoff or tile drainage, this would be the graph on the upper left. We can see that on these sites where we're doing both surface and tile, we're seeing more flow through our tile systems than through our surface runoff on an annual basis. About 3/4 through the tile compared to 1/4 through surface runoff. If we're looking at TSS yield, which would be a measure of sediment loss, we're almost all looking at surface water runoff as going to be our main driver for soil loss. We just don't see a whole lot of sediment movement through our tile systems. In particular, as our tile systems move to a more modern plastic tile, we see even less sediment movement. We have seen some instances in the past where we have older tile systems, whether it be clay or concrete tiles, where we tend to get a little bit more sediment in the tile system, but it still pales in comparison to the amount of sediment that surface water runoff can move. If we move on to phosphorus loss, which is in the lower left, the story is similar to soil loss, where we're going to see most of our phosphorus loss move through our surface runoff compared to tile. We do see a little bit in the tile, but overwhelmingly 86% of our total phosphorus is moved through surface runoff. So that's a pretty big fraction. And if we're going to focus on ways to reduce phosphorus movement to surface water, we really have to focus on that surface runoff fraction. As we move into nitrogen, which would be on the bottom right, this is where the story shifts a little bit. And this is where we're really going to look at that tile portion. If we're concerned about nitrogen and nitrate movement in particular, we're going to be wanting to focus on that tile flow and not surface water runoff, because we see 95% of our nitrogen movement move through the tile compared to only 5% through surface water runoff. So that's what I'm going to focus on today, is that tile fraction and how we can really different things we're looking at to manage that nitrogen loss through the tile system. So first, this would be a graph looking at all of our sites across all of our years of data. So a number of different data points. Every one of those data points is a site year of data. And here we're plotting up annual tile flow on the x-axis versus annual nitrate loss. And you can see there's a very good correlation there, a linear correlation, where we get about 4 pounds per acre nitrate for every inch of drainage. So as we get more drainage, it moves more nitrate. We do see some scatter around this line, and these are the things that we do have control over in terms of what our nitrate concentrations are in our soil water. And so as the circles are smaller for the smaller concentrations and lighter green, and as the circles get bigger and darker, that means our nitrate concentrations are higher. So we really want to focus in on how do we get those lower concentrations of nitrate, and we can minimize the amount of nitrate loss through our tile systems. So if we're looking at nitrate concentrations, this is a chart that kind of shows the same data, but groups different concentration sections. So if we're looking at 6 inches of drainage, and that's a pretty good number, average number for Minnesota. If we're in that 10 to 20 milligrams per liter nitrate concentration, we can really reduce our loss substantially compared to, if we're looking at that 40 to 50 milligrams per liter concentration. So at just 6 inches, a loss can be tripled just by a simple increase in concentration. So we really need to focus in on what's impacting those concentrations and how we can manage those concentrations in the soil profile. And here's some data from a Purdue extension document, which I think sums up a lot of our thoughts on different nitrate concentrations in tile lines. So on the left here, we have nitrate concentrations in tiles less than 5, 5 to 10, 10 to 20, and greater than 20. So what we're really focused in on is that greater than 20 area. When we look at our data and we have sites that have greater than 20 parts per million nitrate through our tile systems, we're really looking and analyzing the nitrogen management of those systems, whether nitrogen rates or timings may not be synced up to crop needs, and we can look at different ways to better manage nitrogen on those sites. And I think the exciting thing about this, so the research that we do is very intensive and has a lot of very expensive equipment that takes a lot of time to operate to get very high quality results. So we did a project with the Wisconsin Discovery Farms a few years back, looking at different sampling strategies with tile systems to see if we can't get similar results compared to a really high quality, high cost data system or data collection system. So on these sites, we were doing all our full instrumentation with our flow-based sampling, automated everything. And then we were also going out and taking grab samples from the tile outlets every 2 weeks on these sites as well. And just sort of comparing our biweekly average to our flow weighted mean concentrations for tile nitrate, we get a really good relationship, a really good one-to-one relationship. And what this shows me and what this showed us was that for tile nitrate, if you're just looking to assess the nitrate coming out of your tiles, you can do a really good job with just grab sampling on a biweekly basis. So the approach to getting data from your fields or your farms is really not that far out of reach, and that can be a really important data source for you when you're looking at your nitrogen management program. So when we're talking about tile nitrate, touched on this before, but our main focus is on that proper nitrogen management and focusing in on the 4 R's. So that right source, right rate, right time, right place. And for nitrogen, we really focus in on that right rate. So creating and applying for university recommendations. And then the right time, whether that would be for nitrogen, applying closer to crop need can provide some water quality benefits to make sure that that crop is going to be able to utilize those nutrients. So another thing we're looking at in terms of managing tile nitrate, and I think there's been work done, there's been lots of work done on this on plot scale and in the different states, looking at the ability of cover crops to reduce that nitrogen load in your tile system. We've started a couple of projects in Minnesota trying to demonstrate this fact of applying cover crops and reducing that nitrate load to the tile system. And one of those projects is in Redwood County, Minnesota. And this project was started in 2017. It's a paired basin design with surface and tile monitoring. And basically the project was set up where there were two basins on the same field. Both basins were managed the same for the first 3 years. And then in 2021, the cover crop was only established on the north site, but not the south site. So in 2021 and 2022, we got some data on how the impact of that cover crop. And the unfortunate thing, and sort of the reality check of doing work like this, where we're doing work in the real world on real farms with real climate situations, was that we had a substantial drought in 2022 and a pretty good drought in 2021 as well. So while we had everything set up to get some really good data in terms of trying to find some impact due to the cover crop being grown on the north side compared to the south side, we just didn't get hardly any tile flow because of the climate conditions. So that's just sort of the reality of this data collection. And I think for me, it provides a really nice reality check in terms of, yeah, we might be doing all the right things. And in certain years, hopefully we're going to see that benefit and be able to show that benefit. But there's going to be certain situations in the real world on real farms where things just don't work out as planned. We also have started a similar site in Stearns County. So our site our site in Redwood County was a pretty traditional corn soybean farm for southern Minnesota, probably less lower tillage than what we would consider traditional for southern Minnesota, but growing corn and soybean in rotation with cover crops. The next site in Stearns County, where we're going to be doing a similar project with a paired basin approach, is more of a dairy forage rotation with corn silage, soybean, and wheat. So a lot more opportunity for establishing cover crops after that corn silage and wheat crop. One of the big challenges we have in Minnesota in these corn soybean farms is establishing cover crops. So that has been a challenge in our Redwood County sites. I think in Stearns County, we're going to have more of an opportunity to get more robust cover crops, more diverse cover crops going with these dairy forage rotations. And so similar with this just started, 2023 will be our first year, similar to the Redwood County site. We're going to go for a couple years to get baseline information. And then as we move forward into the future, cover crops will be taken away from one of the basins and planted in the other, with all other management variables remaining the same, just to get a handle on how or on what the cover crop impact would be in this area of the state with this cropping rotation. Along with those different practices we're looking at to manage tile nitrogen losses, we also started a new project in southern Minnesota in Waseca County at Farm America, which is a nonprofit organization that has a very nice visitor center for the public, looking at the history of agriculture throughout the years in Minnesota. It's a very interesting place, and I think a very cool spot to do a study like this. But we were able to start a controlled drainage project at this site, install new tile this last fall, and look at, we're going to be doing we have 4 different basins we're going to monitor on this section, and we're going to control 2 of them and not control the other 2 to see if we can have some impact in terms of water quality benefits for tile drainage, and also potentially yield benefits for crops if we can hold some water back. So the idea behind control drainage would be to, we installed water control structures. You can put in boards to hold water back throughout the year or release water when you want to. So just more control over when you drain and how you drain. So we believe there's potential in this practice in helping reduce nitrogen losses through tile. So this project will be a good demonstration in terms of showing people how it works, getting people out there to see what's involved, and then also collecting data on the water quality and the yield to show people how it's working in terms of performance on the water quality side. So with that, I'll wrap it up. So for the tile drainage portion, we're really looking at those 4R practices for managing your nitrogen, and then we're looking at cover crops to reduce that nitrogen movement to the tile, and how we can get those to work in our climate. And then also practices such as controlled drainage, things we can do in the field to potentially reduce that nitrogen movement as well. So those are different ways we're attacking that issue. So with that, I can take any questions.
Yeah, thanks, Tim, for that great presentation. So you do have a couple questions in the Q&A box. Can you describe what kind of effect tile drainage has on groundwater recharge?
Sure. So I would say, in speaking only for Minnesota, not much, because the places that we're draining had very poor internal drainage in the first place as a result of the glaciers and how they created our soils and landscape, however many years ago that was.
All right, then I have a question from Jamie Byer. Our county's soil and water conservation districts have programs for cover crops and no-till to reduce erosion, but not tile. Do you have any comparisons between what a tiled field does versus the same acres of a cover crop or no-till?
So what a tiled field does in terms of conservation, not really. So where we typically tile, it's hard to get a comparison of tiled versus no tiled because of the landscape. And where we tiled, you typically don't have the sort of landscape and monitoring capabilities to do surface water runoff without tile. So I don't have any direct comparisons that look at the tile versus cover crop or no-till. But I would say that in general, I think tile can help us do more conservation practices like that, whether it would be allow us to get into a field a couple days earlier to get that cover crop going, or to remove some water from that soil profile so that we don't feel we need to till to dry out the soil as much, and we can do some more reduced tillage. So I think it's more of a question of what tile helps us do in terms of additional conservation practices than comparing those different situations.
Great point. Another question here about, I think this is about the monitoring methods in that joint tile project. Does the grab sampling trend also work for phosphorus loss?
No, it does. It does
results?
not. Yeah. So we looked at it for phosphorus, dissolved phosphorus, nitrate, and sediment, and the only thing it worked really well for was nitrate. Phosphorus is too it moves more up and down throughout the year, and where nitrate is more consistent.
Okay, a question here on I think we'll save that one perhaps till the end. Dean, I think we're going to save your question on overwintering cover crops until the end, if that's okay. And then a question here from Les Everett. In addition to on-farm nitrate reduction practices, are you looking at nitrate removal in drainage district water retention ponds? Drainage water storage is essential in the Minnesota River Basin to reduce stream bank and bluff erosion, and also could reduce nitrate concentrations.
Yeah, great question, and good point, Les. I would agree with your point there. We have not done any work on drainage district retention ponds. Have always focused on the past on in-field practices and on-farm practices. But I think that's a very good point and good question.
Yeah, I think there's some interesting questions that I've heard in a few different places lately about the um, how we're related, how the things are related between like the water that we're holding back and the climate change emissions pieces of that, and what all those different pieces look like together. So it's a great question. Okay, then last one for you, Tim. Will the tile paired basin study in Waseca County also monitor for phosphorus loss?
Yes, it will. And so I didn't talk about all the things we're monitoring, but we'll monitor all the same constituents that we do at all the rest of our sites. So that would include TSS or sediment, and then total phosphorus, dissolved phosphorus, and then 3 different forms of nitrogen as well.
Awesome. Okay, well, those are the questions we're going to take from you for the moment. So thanks, Tim, for that great presentation. If you do come up with more questions for Tim, go ahead and just put them in the Q&A box and put his name next to it, and he can write a response, or we can answer it at the end. So, too. All right, now it's time for us to take a trip south for a session from the Discovery Farms Arkansas program. I mean, going south sounds really appealing right now, Mike, because this everlasting winter in the Midwest is getting old. So today we have Dr. Mike Daniels with us. Mike is a soil and water conservation specialist for the University of Arkansas System Division of Agriculture's Cooperative Extension Service and the co-leader of Arkansas's Discovery Farms program. So Mike, go ahead.
Well, thank you, Amber. It's my pleasure to be with you all this morning. I look forward to this any four-state events with Discovery Farms, because it's a chance for me to learn a lot from my colleagues in other states. And can everybody see my screen okay?
It looks good, Mike. Thanks.
Okay. Yeah, I want to talk a little bit. I'm going to change a little bit. I'll show a little bit of data, but I really think we have a lot of new things going on in the Arkansas Discovery Farm program, some new initiatives that I really want to talk about how we're expanding our program somewhat. We do on-farm research and demonstration, and that will always be the foundation for our program, like the other states. But we're trying to add education now into our Discovery Farm program. And let me just go through real quick. I always like to show some of our sponsors. We do not have a slug of money coming to us on an annual basis, so we have to go out and find grant funds, donations, other things, and we've had a lot of sponsors. And I think the great thing about Discovery Farms is that everybody, it seems like from lots of different sectors of society, embrace this program and see the value of it. And so we feel good about that. And I think that's true for all the states involved in Discovery Farms. Just a shout out to some of our team. Our team has really expanded. We do have lost a couple key members to retirement. Andrew Sharpley, who helped found this program in Arkansas with myself, has retired, but he's still actively involved. Bill Robertson, who really led our cotton farm Discovery Farm effort, is retired, but still involved. He just sent me some slides last night. You'll see a couple of those today. We have other faculty members. We have three new faculty members in the Department of Crop, Soils, and Environmental Sciences that have come since August and later, but that's Dr. Shannon Spear, Dr. Gerson Drescher, and Dr. Brant Fitch. Shannon's going to be working on water quality and really implementing our Discovery Farm watershed project. Gerson's working on our Discovery Farms on characterizing soil health and soil fertility. And Brant Finch is going to be working on our livestock farms, looking at pasture management and more sustainable pasture management. And then we have a lot of different people that actually make the program run, that do a lot of the infield work for us, and you can see all of them there. And I think some of them are with us today. I think Pearl is on with us today, Pearl Webb, and Lizzie Herrera, who does great work with us on our horticultural farms. I think one of our county agents, Lance Blythe, is with us. And I think Bill Robertson's on with us, and Holly Yateman is on with us. And Holly kind of coordinates educational events with local high schools around our Discovery Farms to bring kids out to learn about conservation and farming. And then another one that I know is on today, and I've borrowed some of her slides, but Dr. Tamika White is on, and I'll talk more about her role in Discovery Farm and what we're doing there. Some of the conservation issues that we face that we're trying to address here in Arkansas is in eastern Arkansas, we withdraw more groundwater than we're getting recharged, and we're dropping our groundwater levels. And the state has deemed several areas as critical, and we have to become more efficient with our irrigation. We're in a situation, Kim talked about drought, but we're in a situation in Arkansas to manage and minimize risk. We irrigate about 95% of our crops. And we're the third leading state in the United States in terms of groundwater withdrawal for irrigation. We do have a lot of soil health, soil quality problems that we have not paid attention to. We're like a lot of states. Our focus on soils, on managing soils, is managing the fertility. But there's so much more to soils that we have to be able to use to our benefit. Obviously, water quality is always going to be a foundation of our program. But what we find is soil health, climate change, some of these other things are a part of water quality, factors important in water quality. But we set all of Arkansas drains to the Gulf of Mexico. And with the hypoxic zone down there, it's always going to be an issue of us making sure that we're most efficient with our nutrients. We're also now moving in heavily into climate change resiliency, and I'll talk about that a little bit. Profitability is something that, I think there's a myth out there that conservation won't pay for it itself. We have some situations, especially found in cotton with Bill Robertson, that may not necessarily be true all the time. And we're also looking at sustainability documentation for supply chain. Our cotton farmers, and that's the crop I think is out in head, but I think you're going to see your other row crops, rice, for example, really starting to be concerned about wanting their farmers to, those that buy their crops, their commodities, they want to have documentation that they're using the most sustainable practices. But I think the big thing that was often overlooked, and Tim touched on it, but I think that the great thing about Discovery Farms is that we're involving farmers in the solution process. And what I mean is, if we find an issue, we have the farmers involved in trying to come up with a solution. And to me, why would we discredit the farmer's knowledge of his own land and his own capabilities? That's expertise and things that we need because, as our first speaker pointed out, one size doesn't fit all, and it's almost site specific. It's almost we have to know more about that particular site to come up with the right practice. So it's very important. And I think this is one of the most important parts of Discovery Farms, and this is why it makes Discovery Farms so successful, is having those farmers involved from the very start. We have farms now all over the state. Not been very good at retiring farms. We keep adding farms. But that just gives you a perspective that we're trying to put some things there. And obviously the most important part of this, and the reason we do it, is not for ourselves. We do it for our farms and our farmer families. These are just some of the families that are involved in our Discovery Farm program. I don't have all their pictures, but there's a lot of them there. I like this slide. I show it every presentation, but our program is really led by our farmers. And we sent a delegation up to Wisconsin from Farm Bureau of about 20 Farm Bureau members to talk to farmers in Wisconsin to try to sell the program. We didn't try to sell the program to our farmers. We knew it might be highly emotional. Farmers might reject the idea of us doing monitoring on their farm. So we let Wisconsin farmers, and this happens to be Joe Brager from Wisconsin, who I think is now the president of Farm Bureau in Wisconsin. But he just mesmerized our audience from Arkansas about the benefits. And so he really helped sell the program in Arkansas. We always want to give him a shout out for that. What do we monitor on Discovery Farms? Well, just like the other Discovery Farms, we're monitoring field hydrology, nitrogen, phosphorus, and suspended runoff, or suspended solids and runoff. Bill Robertson and Cotton has added the field to market field print sustainability metrics. We feel like that's important as just a self monitoring device for farmers to use. We want to do it in the other crops. It's just not as far along in that. We're starting to do a lot of soil health selected indicators, and this is Matt Fryer that used to work with us as a soils instructor out monitoring infiltration in some of our fields. And I'll talk a little bit more because Dr. Keyshawn Mahmood, who I think is on with us today, has joined us and is a postdoc fellow in soil microbiology. And for the first time, we're really trying to characterize what kind of soil microbiology we have. And we're starting to look a lot more at what I call climate change services, because I think agriculture in Arkansas can be a service to climate change, and we've got to be more resilient, obviously, to climate change too. And this is just a graph in the middle showing that what we've seen over since 2010 to 2014, and then you look at 15 to 20 in these 5-year increments, we've had the highest number, and it's not even close, of extreme precipitation events. Those events that we classify as over 3 inches. And we've seen that, and we've measured some of those storm events on our Discovery Farm. And so in the last 5 years have been the wettest 5 years on record in Arkansas, but also the driest 5 years in particular times of year. So we're going from extreme flooding to extreme drought all in the same year, and it's making management and risk much more difficult to address. And we're getting a lot of these 3-inch extreme highly intense precipitation events. And so we're going to have to help our farmers deal with climate change and how we become more. Some pictures of some things. If there's any water on that farm, we're going to sample it. When we look at runoff, we have to account for every drop of water that goes on there. So we measure precipitation, but we also have to measure irrigation. And this is up in the upper right-hand corner, Dr. Chuck Wilson, who's retired, but we have data loggers on irrigation flow meters so that we'll know every drop of water and when it went on that field. So we have an added dimension of we don't do any tile drainage in Arkansas, but we have to monitor the irrigation water too, both the quality and quantity. Some of our new farms, we've got the horticultural farms that Lizzie Herrera and Dr. Amanda McWhirter lead. They do a tremendous job, but they're really looking at peach production and how to irrigate. Peaches require a lot of water, and they require water at a time of year you might not expect. It's not just during the growing season, but it's also in the fall, because water is needed, and we're typically very dry in the fall, but that water is needed for bud set. They also are now looking at sustainable practices in strawberry production, and so we have those 2 horticultural farms there. We have we're now looking more, sometimes on these farms, we're looking at more of issue-oriented type farms. We are putting a lot more poultry litter on row crop, and we really have never done that. And nor do we have a good research base for recommendations on how to best manage that from both a profitability, production, and water quality standpoint. We're working with Anheuser-Busch on their Smart Farm initiative, one of their corporate sustainability issues. We want to reduce the amount of water that we're using in our rice and become as efficient as we can. We've also looking at being the most efficient as we can in nutrients, because most of our rice is grown under flooded conditions, and it changes how we manage our fertilizer. Here's some new and ongoing initiatives that I wanted to talk about today. I'm really excited about some of these. The Arkansas Discovery Farm Educational Center with the University of Arkansas Pine Bluff. They're our 1890s historically Black university. We're very excited about working with them. They have a Discover program. It's not the same as an Ag Discovery program where students come in the summer, but one of the things we kept getting, and Holly Yateman has helped us with contacting local high schools to see if they want to come to our Discovery farms, and that's great. But what we have found is that sometimes we run into some problems. We got a request last year from some charter schools. They wanted to bring 240 students out to one farm at one time. And the logistics of that is just very difficult to deal with. You're talking about just having, a farm just had a shop with one bathroom in it. You got 240 kids. we had to tell them, look, we'll do it, but we're going to have to do it in increments. And it got us to thinking, though, we got so much interest. And then Dr. Bruce McGowan, the dean at the University of Arkansas Pine Bluff, called me one day and said, hey, we'd like to work with y'all on discovery farms. And we decided this educational center would be really good. And I'll tell you why. They have an on-farm, a 50-acre on-farm facility, on-campus facility. And even though this is not a private production farm, it is a university farm. We plan, and Dr. McGowan has said, hey, take that farm and use it as a discovery educational center. So we're going to try to give students at UAPB and other universities, but also K through 12, a place to come and get hands-on experience with conservation. Our plan is that we're going to put several different types of farming practices out there. We're going to monitor those practices on farm. It's also going to be a place that we can bring in and help historically underserved farmers with their needs. And so we're very excited about that. Dr. White has already secured some funding for this. So we're going to be working together to get that established. We're also going to establish our first aquaculture, our fish farm, discovery farm, that we think will be very useful to help people that produce both bait fish and catfish in our state. We also know, and trying to do somewhat follow Wisconsin's lead on Discovery Watershed, but we have a new faculty member, Dr. Shannon Spear, and she's already got a sampling plan, already started collecting samples in Brush Creek, which is a tributary to the Beaver Lake Watershed in Northwest Arkansas. And the Beaver Lake Watershed, that lake is the drinking water supply for over 500,000 people, and that's growing every day as Northwest Arkansas grows. And so we've got to protect that lake. It's the lifeblood of that region in terms of water quality. We've been doing virtual field trips for years, but I wanted to bring that up. I want to talk a little bit about the impact it's had on getting the word out about what our farmers are doing. We also started monitoring potassium and sulfate in our runoff. Not that they're water quality concerns, but they could be profitability concerns, and we're trying to learn better. And we have some poorly drained soils where we get a lot of runoff. In fact, in a lot of our sites in eastern Arkansas, about half the rain, not quite half, but about half the rain that we get annually runs off. And so we have to be able to start capturing more of that water in our soils. And I think that's where soil health comes in. And one thing that we've not done a good job in our state over the years is really characterizing what our soil microbiology is in terms of soil health. And Dr. Mahmood has come in and he's gone to several discovery farm sites and collected a lot of data. And then he's also brought this concept that we have one farmer that applies compost. He makes his own compost and he applies that on 6,400 acres. And he's been using a commercial inoculant to try to stimulate the microbes and put microbes into the compost. And Dr. Mahmood has come in and really generated a lot of interest with this locally effective microorganisms, where they go to areas that have never been plowed or tilled or farmed that surround that farm. They collect leaf litter and soil, and then they feed those microbes to build the population in a liquid form that they can spray right on their compost and inoculate it with locally effective microorganisms. So we're excited about that work that's going on Discovery Farm. And let's just talk a little bit about what we're trying to do here. Dr. White, I was on her PhD, a very, very hard worker, very talented. She's a tremendous, she doesn't shy about going after grants, and she does a great job writing grants. And she's currently the interim scholarship director. And one of the reasons we wanted to do this also is that Tamika has secured $2 million of scholarship money for students at UAPB to go into the agricultural sciences. And we're having a hard time getting students interested in agriculture, but they are interested in conservation. And so we want to be able to develop a educational center with hands-on and use soil and water conservation as a gateway for students to gain interest in agriculture. And so that's what we plan to do at the educational center. We're also going to plan to do a climate smart extension program for historically underserved farmers because they face unique challenges with their resources and other things from a climate standpoint. Also, Tamika is putting together a mobile agriculture and aquacultural discovery farm lab that can go and collect samples and work with farmers directly and try to give them some quicker results on where they stand on water, soil, and that sort of thing. But we really want to influence youth to pursue careers in soil and water quality, quantity, conservation, and other things that support agriculture. And so we're going to really put a lot of emphasis on K through 12. We want to develop 4-H clubs to be looking at conservation more. We expect to have a lot of field days and summer camps. And the fact that the farm is right on campus is very advantageous to try to do this. But we also want to, NRCS in our state has struggled to fill all their positions. And by the way, Terry Nels is on here with us today. And Terry was the state water specialist in Arkansas as we were getting a lot of our discovery farms going. And she was tremendous in helping us find NRCS programs that would help with resources and that sort of thing. And so shout out to Terry. But we want to do workforce development through this effort too. And this is just a shot of some of the things they already have going on through their Ag Discover program. But this new Discovery Farm Center will give a place here for them to go to and to utilize. So UAPB does a lot of these type of summer camps and things for youth, and it's just going to be another tool in the toolbox for them, and we're excited about it. Our soil and water field trip series, we have 14 of these 1 hour long series on YouTube, and now we're going back and dividing up these into 5-minute increments. Pearl Webb is leading that effort, but Dr. Julie Robinson and Rita Watson led the effort of producing these. They worked with us on the Discovery Farm. It's tremendous because it's really brought awareness, but this was initiated in 2018 with funding from NRCS. Our plan was to do 3 per year over a 3-year period, but they were so well received, we ended up doing 14. We used a lot of discovery farms at host sites. We did this before the pandemic, but it put us in a place to really do some good things during the pandemic because we had already worked through some of the problems and some of the problems that we have doing these live field events where we don't have the infrastructure in terms of the broadband internet availability across our rural parts of our state. But usually they were 45 minutes to 1 hour. I think people that are highly interested in conservation will take that time, but we also know that a lot of the YouTube generation, they don't want 45 minutes an hour. They want a 5-minute thing that they can walk, and I think research shows that. So we're going back and dividing it up, trying to make it where people might see more. But not only did we do that, we put lessons together for a high school science classroom. So these 14 field trips have a written curriculum. I just wanted to, oops. I'll show that in a minute. Here's the thing. When you look at all the numbers of where people participated in our virtual field trips, they participated from 27 different states. And so, and to me, the important thing about that is not to show our impact, but it's people around the country getting to see the impact of what our farmers are trying and doing to be good stewards of the land. And that's what this program's all about, is letting the farmers and trying to help the farmers tell their story, but in a scientifically valid manner. We had 6 countries, Canada, Egypt. And by the way, I saw that Don Flatten from Canada, Don's retired now, but he did a lot of phosphorus work with Andrew Sharpley. And so we're glad to have Don on today. Shout out to him. But these are the countries that have watched our videos, and they're still up on YouTube. So these numbers will change. But this just is what a trip of what what this looks like in terms of a lesson plan that's been approved by the state to be taught in our high schools, 9 through 12, with all the, I think they're called strands and those type of things. But Julie's group put these together to hand out to teachers. I want to talk a little bit about a horticulture discovery farm. It was the first Arkansas discovery farm to focus on specialty crops. And I've been minimally involved in these because Amanda McWhirter and Lizzie have done a great job. This is Steve and Mark Morgan, and Mark is now the third generation peach farmer in Johnson County, Arkansas, one of our largest operations. And they came to us and were concerned about some of the ramifications of the new Modern Food Safety Act. I think I'm saying that right. But, you know, when we got with a farmer, and when we go on discovery farms, we don't say, hey, you need to do this or that. We go on discovery farms and we say, what do you better want to understand about water? And one of the things they wanted to do was be able to better understand water use and demand. When do we schedule irrigation? They also wanted to be able to say, hey, we are meeting the Food Safety Modernization Act. I think I said it right that time. But we wanted to be able to provide specialty crop growers because we have a lot of specialty crop growers. They're smaller farms, but we have a lot of those farmers in our state. Well, to help them with irrigation, they installed 2 soil moisture sensors in newly planted and established peach orchards. They monitored and recorded the water application patterns. Irrigation partnered with us on this. But we put also a weather station in, and then we just looked at all the data. And they have several ponds that they irrigate out of. And so we took monthly water samples, or they did, from ponds to assess the water quality, primarily E. coli, to make sure that they were meeting those new regulations. And this is just one of their water samples. You see there is some E. coli, but very small, low levels. And you expect from a farm pond, you're going to have some E. coli in it. But they're at levels that we would deem safe as far as using for irrigation and not being a risk to food safety. You know, they were able to get this soil moisture data now on their phones through telemetry, so they could better look at when they need to irrigate. They found out they had to start irrigating earlier in the spring, and they had to irrigate later in the fall. And then what we found, Mark is just a super, and I encourage you, I'll have a thing up at the end to go find his video, but he does a great job talking about how discovery farms and what it's meant to them and how it's helped them. And he's already got plans for installing more sensors on their farm. They like that technology so much, and it's helped them and so much. And so Amanda and Lizzie have done a great job there. I want to talk now, just kind of finish up. I've talked about some of our new, and I don't have much on the Discovery Watershed, but you're going to be hearing more about that as we get closer and closer to receiving funding for that. But I want to talk a little bit about some of our just key results overall. We did find that we are losing a lot of potassium, and I think I focused on this last year's, but we have got to do something to hold potassium in our poorly drained soils. We're losing enough that we can fertilize the crop next year. It's not a water quality concern, but it's a profitability concern. Tim mentioned as you get more nitrogen off. We're finding in all of our drainage in Arkansas is overland flow and runoff. What we find, the more runoff we get, the more nitrate loss that we get, and the more phosphorus, soluble reactive phosphorus that we get. And we focus a lot of attention on everything, and a lot of people think, well, we're over fertilizing. I don't think that's the case. I think the case in Arkansas is on our poorly drained site, we've got to do more to focus on reducing runoff. And it's not so much always about the source, but you know, the loss is some function of the interaction between source and the transportation mechanism. And runoff is certainly our mechanism, our transportation mechanism. We got to do more to try to figure out how we can work with nature to improve runoff on these poorly drained soils. And one way we're doing that is with cover crops. And this is Steve Stevens, who never had a cover crop, and now he plants in standing annual rye and cereal rye. And this is work that Bill Robertson did with him. One of the concerns he had was, could we still get irrigation down our furrows with all this heavy residue? Bill found equipment that we call almost no-till. It really does minimum soil disturbance, but it sweeps the residue out of the middle so that irrigation water can get down there. But everybody said, don't do this, don't do this. And we found there's been a lot of benefits to this. And one thing that we found is that where we have cover crops in that cotton, we get response, and this is the 6-inch is right here. Here is the, and you can see that we have in the cover, well, here's the 6 inches, the orange, the gray is 12-inch, 18-inch. Look at this. Every time we see a response to 6-inch, we're also seeing it at 12 and 18 in terms of the soil drying out, which means roots are extracting water down at 18 inches. Where we don't have cover, and this is traditionally what we've seen in cotton, and this is why we have to irrigate so much. When we get a response at 6 inches, we're not seeing it at the other depths. And so we're extracting water deeper in the profile. We're getting water deeper in the profile. What we found on the no cover side is we have water deeper in the profile. The plant roots can't get past our restrictive layer to get down there to get it. But when we open it up with cereal rye, and we've tried mechanical, means of what we call ripping the soil deep tillage to try to break it up, but that only lasts for so long and it creates other problems. But it seems like the cereal rye is a natural process for breaking up our poorly drained soils. And so this is something that we're going to continue to look at. And we've seen this all over the state, these water use patterns. These are some slides that Bill sent. Even though he's retired, he's still working hard on this. And this is up at our Judge Hill plantation. It's a farm that was willed to the University of Arkansas State, but the fields are privately farmed. But we have access to get out there and do work. And we start with what the farmer standard or what they've always done. This is the spider diagram that you get from field market footprints. But look what happened on the farmer standard. You can see the operating expenses, the yield. But look what happens when we do cover crop. And this is where we're talking about, and we've seen this at 2 sites that we've studied intensively. Here's the yield is down a little bit, but look, the operating expenses are down a little bit, so that when you get down, we're producing cotton just as cheap or cheaper, which means more profitability where we do have cover crop. Data being collected. I just wanted to kind of go through some conclusion here. Data collected from all farms indicates that less than 5% of N&P being lost relative to N&P applications. From an agronomic standpoint, that's low. Reason we want to go to, but low is a relative term, and the reason we want to go to a watershed is what does that mean for the overall receiving body? And so we don't know that. Shannon, I think, is going to help us answer that. But we do know that when we're getting these losses that are this small, what else can we do? And I think some of the things that Tim and others have pointed out is that we have to stack practices, and we also have to think about being more site specific and using conservation farm plans to help address and tailor to that site specificity. But we've got to have more research. One of the great things about Discovery Farms is everybody wants to come out and see it, whether they're farmers, whether they're politicians, whether they're just people that don't know have any background in farming. And we've just had a tremendous number of tours over the years. We just had 200 last fall from the private lands program. One thing that we have done is we don't really have an outlet for yearly report series, but we did, at the invitation of Nathan Slayton, he asked us to come into the SABI report series, which is on soil fertility. But we put a special session on Discovery Farm. I think we had 12 publications put in there. And we're looking at trying to secure funding to be able to do this on an annual basis. Shannon Spear and Chris Bry and myself are all looking at this. So that's where I'll end. If you want to know more, see that video with Mark Morgan, or know more about our horticultural discovery farm, I think you can take a picture of this QR code and it'll send you there. If not, you can go to the Arkansas Discovery Farm's website. We're also on Facebook, Instagram, and Twitter. And if you would like to contact me directly, I have my email up here. And with that, I'll turn it back over or answer any questions.
Awesome. Thank you so much, Mike. It's great to see all the different happenings that you've got going on down there. I think what I'll do is, just so we might be able to have some time at the end for questions for everybody, I think we'll go ahead and have Vermont do their presentation, and then we can come back to any questions that we get in that time. So our last state represented today, which is smallest in area, but certainly not in impact, we have to hear from our partners who have started up the Discovery Farms program in Vermont. Our speakers from Vermont will be Dr. Heather Darby, Dr. Joshua Faulkner, and Ivy Krasinski. Dr. Heather Darby is a professor and agronomist with the University of Vermont and the project director for Discovery Farms Vermont. Dr. Joshua Faulkner is a research assistant professor and coordinator of the Farming and Climate Change program at the University of Vermont. And Ivy Krasinski is a research specialist for the UVM Extension Northwest Crops and Soils program and is the lead for coordinating Discovery Acres. So with that, you guys can go ahead and take it away.
All right, thanks, Amber. I think I'll start things here. Let me just get my screen shared. Okay, great to see so much other Discovery Farms work from the other states. We're the new Discovery Farms on the block, so we don't have quite the track record that others have, but we have been doing work that is similar to Discovery Farms in Vermont, I think, for some time. And so we're going to take a chance to talk about some of that work today. I'm going to start with a project looking at aeration prior to manure application in hayfields, and then I'm going to hand it over to Heather to talk about some additional, Heather and Ivy to talk about some additional work. Okay, so before I get started, I want to acknowledge a graduate student of mine, Cam Twombly, who did a lot of this work. So many thanks to him. He's moved on. He's employed out in the world now. So fantastic. But this is primarily his work. All right. So just to get started, so we're looking at we had a lot of interest from farmers around the state in aeration, and you can kind of have a photo of what that looks like there in the lower left hand corner. Some of the brand names would be Airway or Gentil. There's a few others out there as well, but farmers were interested in this. Some conservation professionals were interested in this technology. So we said, let's look into this a little more. Some of the study results on aeration, when you look across the country, have been somewhat mixed. Some have actually shown that it could potentially increase runoff from a field. Some have shown that it decreases runoff. Some have shown that it increases nutrient loss or decreases, et cetera, et cetera. So, I think this is one of the big ideas behind Discovery Farms, and this work was, well, we need some local research here in Vermont on our soils, on our farming systems and our climate, to try to understand what the potential impact is of this particular farm practice. So that's where we started. We have a lot of hay ground in Vermont, whether it's in rotation with corn silage or whether it's permanent hay, and this aeration was something that had been happening on farms prior to manure application, surface manure application. So good justification, motivation for us to study this. The other piece of this was that when you look at some of the aeration work that had occurred, very few of those studies were at the field scale. Some had looked at more like plot scale, rainfall simulator work, et cetera. But very few had done it looking at an entire, small watershed within a field. So we thought there was an opportunity there, and very few, if any, have included a full year in the Northeast, a full year's worth, a full year-round monitoring. And I'm just showing some photos of why that is challenging. It's not necessarily so much the snowfall that makes this difficult. It's really the kind of the freeze-thaw cycle, especially during wintertime melt events, or in the late winter, early spring, where we have warm temps during the day, and then it gets cold at night and we have icing, and in these flumes and all this, this equipment that's designed to measure runoff. So it's difficult work, but we thought we'd give it a shot. So here's our site. This is just on a working farm, right on the shores of Lake Champlain, which is our largest body of fresh water there. We have a TMDL, or pollution diet, on the lake for phosphorus. So a lot of concern and funding going into limiting runoff from agriculture into that lake. So we got a couple hay fields on this farm. One of them would be aerated, and one would be non-aerated during the treatment period. This is a paired watershed study design, and Tim mentioned a few of these in Minnesota. And so I don't need to walk through it step by step, but the big idea here is we go through a calibration period where we keep things the same in both of these fields, and then we move into a treatment period where we then apply that aeration prior to manure application. And that way we can account for any natural differences within the field in terms of hydrology and natural nutrient losses. So just a little more data on those two fields down here at the bottom of your screen, just looking at the type of species in the hay field. The size, they're both about 5 to 6 acres in size, both moderately sloped. And they have soils are not exactly the same, but really that Virgins clay and that Covington clay are pretty similar soils in the big picture. They're both high clay content soils, and both really representative of what's farmed in this part of the Champlain Basin. Okay, so for monitoring surface runoff, we have, some of you may be familiar with these. We have stations built at the edge of the fields with wing walls that are designed to kind of funnel water in toward a central flume. And then we have monitoring equipment that automatically pulls samples from those flumes when we do have a storm event and generate runoff within the field. So our monitoring period was one of our longest studies, started in October of 2012 and continued through December of 2018. And like I said, we did our absolute best to try to capture that wintertime runoff as well, because it's good to include that in the total picture, but we also feel like those wintertime runoff events could be especially important in terms of nutrient loss. So we wanted to make sure we captured those and we're able to quantify that. Okay, we also collected forage samples on these fields. We established transects, kind of two transects that crossed in the middle of each of the fields, and collected 10 subsamples across each of those transects. And there you can see one of our extension folks taking forage samples. We did this within hopefully the day before. It wasn't always the day before, but definitely within a week of hay cutting on these fields. Took those samples, dried them, ground them, measured yield, and then sent them off for nutrient analysis. In addition to the surface runoff and the forage yield, we also wanted to try to characterize as many of the other inputs and outputs in these fields as we could. So we had, pretty good estimates of manure application based upon the spreading equipment that the farm was using, but we also took manure samples prior to application. So we got, a good idea of not just what's in the pit, but what's actually going on to the field. And then we also installed lysimeters, which we saw those in, I believe it was Lindsay's presentation. She did a really good job of describing those. These are just, basically ours were cans that were placed underground beneath the root zone, and they're designed to capture water and nutrients that move through the soil profile downward, and that would potentially be entering groundwater or entering tile drainage. But in these fields, there was no tile drainage. Okay, so let's that's what we did. Just go ahead and jump right into some results here. And I don't need to talk about the figure there too much. This is just the approach we use for a paired watershed study, where we look at how regressions change over time from that calibration period into the treatment period. And if we see changes in those lines, if those lines are different than one another, then we know there was an effect of the treatment. So for runoff volume, our first thing we're interested in, we did actually see an increase of just over 16% in storm runoff volume during the study period as a result of aerating the hayfield. So then we took a little bit closer look and we said, well, this is on an annual basis. We're making this evaluation. Let's look at what actually happens to runoff just in the time period directly after the aeration occurred. So maybe, thinking maybe there was some short-term effects here where we fractured those soils and maybe we're getting better infiltration or not. So we looked at the 8 weeks just after aeration, and we did not see any effect even in that when you just look at that period right after aeration. So we saw no effect from the aerator there on runoff. So moving on to sediment loss, and this is where we did start to see an influence of the aerator. We saw reductions in sediment, total suspended sediment concentrations of just over 21% or almost 22%. And then we saw a little bit less of a reduction in the total sediment load. And Lindsay did a really good job describing the differences between concentrations and loads, I believe. But loads essentially are concentrations times the amount of water. So it kind of takes into account the total mass of that sediment moving off the field. So what we're seeing here is we're seeing good reductions in concentrations, less so in the loads, and that's because of that increase in total runoff that we saw on the slide before this one. That's kind of negating some of the benefits of that reduced concentration. And this is really curious that something like aeration, something that actually disturbs the soil surface, would actually lead to some reduction in sediment transport. But there's been a little bit of work on this before. I'm citing a couple papers there, and we felt this was maybe because of just an increased surface roughness in the field. So it's slowing runoff down, allowing a more opportunity for sediment to settle out of that water because that water is moving more slowly across the field. So now moving on to phosphorus. So we looked at total phosphorus and total dissolved phosphorus, and our phosphorus concentrations were reduced by a little over 32%. So good news there. And then we did see about an 18% reduction in total dissolved phosphorus, but this one should be taken with a grain of salt. This was not statistically significant. It was encouraging, but it's according to the statistical approach we use, we can't really say that this was a statistically significant result, but still, I'd like to talk about that nonetheless. And then we saw no significant difference in total phosphorus or dissolved phosphorus loads. So again, we're seeing some influence here on concentrations, but because we're seeing an increase in total runoff volumes, we're not seeing much, if any, of an impact on the loads leaving the field. Moving on to nitrogen, we did see reductions in both total nitrogen and total dissolved nitrogen concentrations. Again, these are nice reductions to see, 25% and 34% respectively. But then really the same story here for, as we saw with phosphorus, that we're seeing the reduction in concentrations, but not necessarily in the load, because we're seeing an increase in total flows leaving the field due to aeration. So then those are results on an annual basis. And like I mentioned, we did this monitoring year round. And we said, well, you know, I wonder if we're seeing if the effect that we're seeing is that different in the summertime or than it is in the wintertime. And that's an important question because we know our lakes are more susceptible to some of the nutrient inputs in the summertime when it's really warm and dry and we have those heavy summer thunderstorms. We could potentially, those are the runoff events that are linked to some of the algal blooms. So we're wanted to understand if this practice is having any effect on those summertime runoff events. And then vice versa in the wintertime, we're seeing more of those winter thaws, rain on snow events and warm periods during the wintertime with climate change. So we want to understand how is the effect of this practice different in the winter, given what the future might look like with a changing climate. So when we teased out the non-winter events, we saw no significant difference, which I think is good news that this is a practice that is at least not increasing the likelihood of those algal blooms and phosphorus runoff in the summertime. And then when we teased out the winter events, that's where we really saw the biggest benefit, which was good news, I think. This is in the wintertime, aeration tended to decrease our total phosphorus, our dissolved phosphorus, our total nitrogen, our total dissolved nitrogen concentrations, as well as here's where we saw the influence on loads. This is where we saw a reduction in total phosphorus, the mass of total phosphorus leaving the field, as well as the mass of total dissolved phosphorus leaving the field. So good news there. It was really interesting to see that difference between the seasons. Okay, so I just want to report here quickly, show some of the data we collected with the lysimeters. This was really enlightening data. And I guess the high points here, we're not going to walk through this entire chart, is that we saw leachate leaving these water leaving the root zone of these fields into the potential groundwater in some cases 5 times greater than what we saw running off of the field. Now this should be taken again with a grain of salt. These lysimeters are a very small portion of the field. You know, this was probably I believe a 10 or 12 inch diameter kind of footprint for the lysimeter. And so we're not actually measuring everything across the entire field, but it is definitely makes us scratch our head and say, maybe we need to do some more work here to look at how much we do have potential leach in these hay fields. And then the other piece here was because of that high leaching volume, we did see meaningful amounts of phosphorus and dissolved phosphorus leaving through the subsurface. So these units are a little difficult to interpret. These are grams per hectare, but if you just do a little mental math and move that decimal place 3 points to the left, that's kilograms per hectare, which roughly equates to pounds per acre. So you can kind of think of these as total phosphorus somewhere between 1 and 2 pounds per acre when you across non-aerated and aerated leaving the field, and less than that, of course, with the total dissolved phosphorus. So, you know, this is I think good information for us, saying we need to do some additional work here. But at the same time, it's not surprising. This is just a picture of a crack in a hayfield from a couple of summers ago. These clays that we work in are shrink swell in nature, and they can create these large cracks, which can move quite a bit of water. And I suspect that our lysimeter just happened to be placed right underneath one of these cracks where we had a lot of surface flow running across it. So it went down right into our lysimeter. Okay, so conclusions from this study were that aeration increased runoff volumes on clay soils in hay fields in Vermont. And that aligns, like I said, there's literature's mixed on this, but this kind of falls on the side of the fence where aeration might actually lead to more runoff, likely because of one additional pass on the field, potential increases in compaction, especially if that aeration is performed when the soils are the least bit moist. Aeration decreased sediment loads, good news there. decreased concentrations of nitrogen and phosphorus, but really had no effect on annual loading. However, we did see the biggest benefit in the winter time during those thaw events, which may be more common and more important, excuse me, as we move into the future with climate change and these winter thaws become more common. We saw from the production standpoint, we saw no significant effect on forage yields. And I didn't have time to show those data. And then we did see this last piece that I mentioned, where we are seeing surprising amounts of water moving downward through the soil profile. And this indicates a need for more research, which we've started to do with our current Discovery Farms project now, looking at tile drainage and subsurface transport. All right, thank you. I want to mention the publication that has much more of these data included in it is there at the bottom, and that's my grad student there, first author. So just want to acknowledge him. All right, I'm going to stop sharing. Sorry.
Yeah, Joshua, can I just have you clarify one question before you move on?
Yeah, absolutely.
Exactly which equipment was used in aerating the fields? That was a question that came up.
It was a Gentile. And I don't know the model number, but the make was Gentile. I could dig that up. Yep.
Awesome, thank you.
Yep, you bet.
Just to do a time check, Amber, when is our group to end?
So you guys can go until like 11:35. We got about 20 minutes.
Oh, okay. All right then. To continue on with some of Joshua's work, and as he mentioned earlier, we are new to Discovery Farms Network, and so much of our edge of field work is just getting started, and Ivy will talk a little bit about that in a minute. But we did want to show off some of the work that we've been doing in water quality and conservation. And this year we really wanted to focus on conservation on hay ground. And as Joshua said, it's a big portion of the agricultural land in Vermont. So the project that I'm going to be talking about was led by a graduate student, Sarah Brookman, who received her master's here and has since moved on to get her PhD out in California, and then also assisted by Lindsay Rule, who's a research specialist here at the University of Vermont Extension, and myself. So just some context, there's Vermont, for those that don't know where it's located, up in New England, in the Northeast, the actual Northeast, and it is a relatively cold spot, although getting warmer, and much like the upper Midwest as far as temperature goes. And as far as precipitation goes, also relatively similar to the Midwest, or the upper Midwest. We are a wet, we have a wet, temperate climate, and you can see we often receive, between 30 and 50 inches of precipitation, and sometimes more each year. So we're cold and we're wet here, and the wet conditions are increasing. I'm not sure if Joshua actually mentioned that, but we're getting wetter, and the intensity of rainstorms are more extreme. And so, of course, that makes conservation more critical, and maybe what seemed to work for conservation even a decade ago needs to be constantly modified and reevaluated. So Vermont is primarily forest land, as you can see through the map. And, it was primarily cleared in agricultural land many years ago. If you missed that, I'll go back and let it run again. But you can see the difference between 1930 and 2012. Over 80% of our state is forest. And so we have a small amount of land that we are managing, both where people live and businesses thrive, but also where we have agricultural operations. And if you look to the left, you can see most of the land-based, agricultural land base in Vermont is actually pasture, hay, and silage, and there are forages grown for hay and silage. And there's very little row crops, fruits and vegetables, or anything else. But most of the time, we have spent actually managing that small amount of acreage for conservation. Always, I guess, usually thinking that hay and pasture, that's the creme de la creme of conservation, right? Both from a climate perspective, but also from water quality. There's always this perception that if there's more grass and pasture, then we have land that's covered and permeable and sequestering carbon. But for most of you that are involved here and probably attending this webinar, you realize that managing hay ground and pasture ground from a conservation perspective, especially when we have this much of it, is extremely important. Let's see here. We talked about this last year, about the water quality regulations in Vermont, both, sort of federally, but also on the state level. We're under a number of regulatory requirements, or agriculture is. The farms here follow the required agricultural practices regardless of the size of the farm. Some of those include, we can't spread manure in the winter. Actually, the spreading ban lifts next week on April 1st or this weekend. But if there's snow-covered ground, regardless of the time of the year, you're not to be spreading manure. So this ban covers a certain period, but there's restrictions, even around that. We have a lot of requirements, for training, even farms, custom manure applicators. Everybody needs to be educated around water quality and conservation, and also really needs to be doing it to be following the law. Most all of our farms, especially our dairy farms, have to have nutrient management plans that meet the NRCS 590 standard. So again, we are a state that is focused highly on conservation as it relates to water quality. And I think, as Mike mentioned earlier, there's not a shift away from water per se, but certainly more of an eye on climate and conservation, soil conservation, organic matter building, soil quality, etc., to help adapt and mitigate climate change as well. For us, we're focused on Lake Champlain as our primary body of water, but of course, there are lakes and streams and ponds all over the state, just like other places. But this is where most of our regulations revolve around, and we're mostly concerned with phosphorus runoff into the lake, but obviously there's other concerns as well. So we have lots of conservation adoption in the state, but that also pushes us to try to be on the forefront of research to help farmers, find the right practices that work for them. And I think Mike mentioned this as well. Our goal is for conservation and farm viability to match up, right? I mean, ultimately, when the two of those make sense on both levels to a farmer, we have much better and broader scale adoption, but that is not always the case. And we do have lots of cost share programs, both federally and on the state level, to really help support farmers in adopting conservation, so that hopefully it's not an economic barrier. But again, it's always ideal when we can match up conservation and farm economics. So again, as far as phosphorus loading into Lake Champlain, agriculture is a big component of that. But I will say, and very proudly say, that agriculture over the last 5 years has also made the biggest impact and biggest reductions compared to any of the other identified pies on this graph. So, in agriculture, we are making changes and making significant reductions. And most of the reductions over the last few years have come from agriculture, and that's something that we're all very proud of. So I mentioned we have lots of grassland, and we have a good amount of manure that goes on that grassland. That grassland is there to feed livestock, and with livestock comes manure, which is a highly valuable resource that we have, and I feel really lucky that we have it in regards to being able to fertilize and grow really high quality and high yielding crops. So we're thankful for that. But as everybody knows, we need to manage it in a way to minimize nutrient losses and other losses, pathogens, etc., into the water, but also into the air. And we have a lot of hilly ground in Vermont, just like parts of the rest of the country. And honestly, a lot of our hay ground tends to be focused on those sloped areas because farmers can't grow corn there or soybeans or row crops. So our landscape, in some ways is very, very conducive to grass and livestock. But that also means we're often spreading manure and nutrients on very sloped ground. And so again, we have to be very cautious about where that goes and how we, manage the manure to prevent runoff. So in Vermont, all farmers are required to have 25-foot buffers from waterways. And you can see here's a hay field that's been spread. And you can see they've actually left more than a 25-foot buffer along surface water, but that is the law in Vermont. So we have that in place to help protect the water. But as everybody knows, you can see the manure that's on this field, and not to say that this isn't an acceptable rate, and I'm sure this farm is following their nutrient management plan, but you get a 5-inch rainstorm with this, and that manure can quickly move. And so, with so much of our land and grass, we've really been trying to figure out ways to minimize those losses. And like Joshua just talked about, a lot of farmers were interested in airways. The other piece here is that, and this is from our nutrient management guide in Vermont, the other piece of this is when we put manure on these grass fields, we're generally applying it to the surface. And then the ammonium nitrogen that's there from the urine can be easily lost, which for most manure sources here in Vermont, that's half of the available nitrogen to grow that crop. So the farmers are applying the manure, almost half of the nitrogen is being lost in total. And then the farmers are going back out and adding more nitrogen in the form of urea to meet the actual nitrogen needs of the forage crop. So again, this is what we use in our planning, and this is what the farmers use. So you can see over here to the left, ammonium nitrogen manure losses can be upwards of 80%, depending on the type of manure. Most of our liquid manure, we see losses of around 60 to 70%. And again, the climate and the conditions at the time of application can drive those levels way up or down as well. But when we're not incorporating manure, somebody suggested that as a practice to protect nutrients and keep them from being lost. Well, when you have all this hay ground, how do you incorporate it? So we have had lots of interest in Vermont in injection. Manure injection is fairly popular on corn ground, of course, and we've done a lot of work with manure injection on corn ground, but it's also becoming increasingly popular on hay ground. Now, of course, there's a lot of challenges to this, which I already mentioned. We're on really sloped ground. Part of the reason those fields aren't tilled up is because of the slope, but we also have a lot of rocks. In Vermont, when you picture those beautiful New England photographs of those long rock walls that people built, those were farms, and those farmers picked the rocks out of the fields and I guess built walls with them, because what else were you going to do with it? So we have lots of rocks, and that's clearly a challenge to both tillage, but also to injection. But again, there's a lot of interest around this, and we have several machines now in the state of Vermont both custom operators and single farms that are injecting manure into grass ground. So here's one that the University of Vermont owns, and we actually work with a local watershed group to operate this. You can see it's a Veenhuis house, however you pronounce that, was imported out of Europe. And you can see it has these metal discs that cut a shallow slot in the soil, and the manure is pumped out of this tube here and goes into that slot. So it's really a very, very shallow injection, and you can see it here. This is, you know, a little extreme. We don't usually see this much manure on the surface, but kind of this is where we were getting started when we were starting to run the injector through our plots. And then to the right, you can see broadcast application. So clearly with injection, we can get more of the manure in the ground and hopefully retain the nitrogen for use by the forages. So the farmers get more out of their manure, hopefully buy less nitrogen, and then reduce the chance for runoff and other nutrient loss on our hay ground. This is a horrible picture, but the pieces we're also interested in that were a part of this study, but less related to water quality and more related to gas losses into the atmosphere. We also wanted to look at urease inhibitors in manure and on fertilizer as a control, as a way to reduce ammonia losses and volatilization into the atmosphere. So I will talk about that a little bit. So we're hoping by looking at manure injection, we would reduce potential nutrient loss, we would increase nutrient retention, which would be great for the farms too, great for the water. But what we didn't really know is what would happen with greenhouse gas emissions. What we do know is that injection on corn ground generally increases emissions, especially nitrous oxide emissions. And we weren't sure what would happen on grass ground. And then, of course, nothing is simple or straightforward. You know, doing one great thing for water quality may not provide a greenhouse gas benefit, could actually be worse. It could be good for economics, could be bad. So there's a lot of trade-offs here, as we know, and how do we balance those and do what's best, you know, for everybody? Seems pie in the sky some days. All right, so I might skip through this to save a little bit of time, but manure injection can increase CO2 because of the, you know, disturbance to the soil and the carbon that's there and decomposition through microbial respiration, especially in grass ground, because you are creating that slot. So there is some disturbance there that isn't normally there. And then with injection, we do generally see increases in nitrous oxide because you have, you know, moisture, you have carbon, you have a lot of nitrogen in a zone that generally is becomes anaerobic and can lead to more nitrous oxide production. So again, our study objectives were to quantify nitrous oxide and CO2 emissions, and then also really to look at yields and forage quality, most simply. So the study was in northern Vermont. You can see the little blip here. It's as far north as you can go. It looks like it's in Canada because it almost is. It's right. That's the road where the line is, also the border, but the farm's right on the US side of the road. It's a silt loam soil, really high organic matter, as you can see. And this had been in permanent sod for as long as I've been on the farm. So the experimental design was applying a urease inhibitor, contain max, to injected manure broadcasted to synthetic urea and a control, which was water, sprayed on the plots, and then no inhibitor with the same treatments. And then Sarah Brickman worked really hard to collect the gases from the plots regularly, and we just saw her out there a lot. And she used a couple of different tools that changed depending really on which one was working the best, but very intensive sampling. And just some highlights, I guess, from the data. The dotted line indicates when the manure was spread. And you can see in the injected ground, there was more CO2 emissions, especially following manure application. You'll see another strong sort of blip upwards from injection, and even the control and broadcast, and that was a rain event. And it was very dry, so we had noticeable blips, increases because it was a very dry year, or 2 years. Both the years were very dry. So you can see in general, especially following, some significant rainfall or manure application, the injection tended to have higher CO2 emissions. And of course, the N2O data isn't quite that easy to follow, but again, you can see when we were injecting, we did see much higher increases in N2O emissions, especially around the time of manure application. And then again, you see that really strong increase, and that was right around the time of rainfall. And we were, again, it was very, very dry. So when that rainfall came in, there was likely a spur of microbial activity and gas emissions as well. Soil nitrate concentrations, as we would have expected, were higher in the injected plots compared to just broadcast. And this was averaged across the inhibitor or no inhibitor. But again, the point of injection is to retain those nutrients and protect them in the ground. And we certainly saw that compared to broadcast. We did go out and measure the yields with this handy little harvester. That's Travis. And we did see quite a significant difference in yields, which was very exciting to us and something we're going to continue to investigate this year on some on-farm studies as well as these replicated studies. So you can see when we injected the manure into the grass ground, we did see a significant boost in yield compared to just broadcasting the manure on the surface. And it was also higher than just using urea fertilizer. Now, interestingly, something that we saw with the yields was that when we added the urease inhibitor to the manure, we did also see a similar yield to the injected manure plots, which our assumption there was clearly that the inhibitor worked to retain some of the ammonium nitrogen and made it available to the crop versus it being lost. And this was over a 2-year period, and I will say that both years were extremely dry, and both years were above normal in temperature as well. So this is a result that we're very excited about because most of our farmers broadcast manure, and if we can retain some of the nitrogen and reduce fertilizer costs, that's a win-win for them. And at the same time, if we're using injection, we also see we're increasing yields, probably able to reduce fertilizer costs and also minimizing nutrient losses. So we'll continue investigating this, like I said, in some on-farm studies this year, going out on 7 farms across Vermont, looking at these inhibitors with and without injection. So I think that's it for me, and I will turn it over to Ivy.
Thanks, Heather. Yep, I'm just going to share some slides here. And I'm just going to talk about our Discovery Farms program here in Vermont and our research site, and just connect what Heather and Joshua and other folks, their research that they're doing here in the Northeast and how that connects to our research site. So you saw these pictures with Heather and Joshua, but I think it's good for context to see where our Discovery Farm site is located. We are up in the northern part of Vermont here. We're in the Jewett Brook watershed in the St. Albans Bay. We're in Franklin County, Vermont, in the northwestern part of the state. We have a lot of agricultural land here, and like Joshua mentioned, we have heavy clay, poorly drained soils. And this watershed is an impaired watershed, so it is a high priority, and there's a lot of research being done on reducing the nutrients going into the watershed. This is an overview of our research site. So it is on a privately owned dairy farm here in St. Albans, Vermont. We're really appreciative of the landowner, the Bissett family, for allowing us to conduct the research here. It was really important when we developed this site to have an active farm where we could really control the treatments that we were going to install on a field scale, because that is really important for farmers to see. And so to share a brief overview of our research, Joshua mentioned this and so did Heather. We are new to the Discovery Farms program. We installed our research site in the fall of 2020, and then we've been collecting calibration data since then. 2021 was a very dry year, very little runoff that year. 2022 was a lot wetter, so it's interesting to see just differences from year to year. But so the exciting part is this spring, we are gearing up to implement our research treatments at the site. So like you saw in the previous photo here, it is a paired watershed design. And 2 of those micro watersheds are not tiled, and 2 of those are tiled. One of the practices farmers are adopting here to deal with the poorly drained soils is system tile. So it was really important to incorporate 2 micro watersheds with tile drainage. And so we're using the edge of field monitoring devices that Joshua explained in his slides to monitor the surface runoff as well as the tile drainage. And we are, with our treatments this year, we're going to look at comparing conventional management practices, what farmers here in Vermont are already doing on a typical year, and comparing that to what we just describe as best management practices. So the management practices that we're looking at were based on what farmers here were interested in and what the farmers were already starting to do on their farms. And so that includes roller crimping, a winter planted cover crop, and also manure injection. And like Heather mentioned, manure injection is getting a lot of interest here on the hay fields, but also in no-till corn silage. So the treatments are going to incorporate the rolled and crimp cover crop as well as manure injection. And the reason we're incorporating cover crops in both the best management practice as well as the conventional management practice, because farmers here, we have really good cover crop adoption here. And so most farms are using cover crops on at least some portion of their fields. So that's included in both. And we're going to be monitoring the water quality coming off the fields with these management practices compared to the best management practices in the surface runoff and in the tile, because we really want to know what the nutrient loss looks like in tile with these practices, as well as soil health. And of course, crop production is really important. We want the farmers to see what impacts these practices are going to have on their crop yields. And just to bring it together here, we are really focused on working with partners in the Northeast and with the Discovery Farms Network. We have an advisory board with farmers here in Franklin County, as well as the agencies listed here. The project was originally funded through the Vermont Agency of Agriculture, and that work has been going on. And then we also received a new grant from the Lake Champlain Basin program, and that is allowing us to continue studying at this site. So we're really grateful for their support. And also just the Discovery Farms Network being able to collaborate with all these states and just sharing this information. So I think that is all for me.
Awesome. Thank you, Heather and Joshua and Ivy, for that overview and some really interesting data that you have in Vermont. So What we'll do now is Tim will put up the code for the CCA credits, and then we'll go ahead and sort of facilitate a couple of questions here to the whole group. But I just wanted to point out that as we're finishing up here, the CCA credits will be on the or are on the screen, and then also as you leave, there will be a quick poll to collect some information from you. So this is anonymous demographic information that helps us evaluate the audiences that we're reaching with this type of work. And so if you can quickly fill that out, it will really be helpful to us. And then included with the demographic information is a question to assess how much you learned from your time at the webinar today. That is your time because it's very valuable. So please take a minute to answer that when you leave the webinar. So for whoever wants to weigh in on this, I think this is such a great question that maybe spans across a few of the programs. This idea of overwintering cover crops and their effects on dissolved phosphorus runoff. Anybody want to take a stab at that?
Sure, I can take a stab at it. I think there is a good question to be answered there. I don't think we have a good answer on terms of if that's an issue or not. I think I've seen some research and evidence of cover crops that maybe winter kill can potentially have the ability to release some dissolved phosphorus. So whether it be looking at cover crops that don't winter kill versus cover crops that winter kill, that might be a good thing to investigate.
Yeah, what we have heard from Mike mentioned Don Flatten in Canada. What we learned from our friends in Canada was this idea, a lot about this idea of plants that die over the winter time and releasing some of that dissolved phosphorus in a way that we don't want it to. So in Wisconsin, we have talked a lot with farmers about, since we have a frozen ground period, that does make it difficult for a lot of those crops to live through the winter, and also really increases that chance for dissolved phosphorus loss with frozen ground and things like that, that we've been emphasizing trying to have at least something that will overwinter within your cover crop mix, just because also having protection in the spring at that critical time period is really something we could benefit from phosphorus, nitrogen, and sediment loss.
Yeah, I feel like we sort of go both, or we've gone both ways, where farmers were really interested in growing a lot of winter rye, and that was working out pretty well. But then as there were some, I don't want to say train wrecks, but like challenges, especially with termination in the spring, timely termination, or what people felt like they needed to do to manage that cover crop and get the cash crop in. There were some frustrations trying to manage rye. So then there was a really strong interest in, well, what about these cover crops that will provide cover, but then they die over the winter, and then we don't have to worry about them the next spring, and we can just go out and do what we want and get going. And so we did kind of play around with that a bit, but we didn't take any sort of nutrient loss data. But I think what the farmers observed was they didn't like the way the fields looked brown the next spring, and they felt like there were some benefits, but also that downside of, well, are we really protecting the soil? Are we reducing runoff at that time that you're talking about, Amber? And so now I feel like we're kind of going back, and people are starting to mix things up, like you suggested, where they're trying to figure out maybe to lessen the volume of biomass the next spring by mixing some annuals, winter terminated stuff. And now people are becoming a little more focused on winter wheat as an option because it heads out later and they have a little more flexibility. It doesn't get as tall and wiry. so easier to manage. And I think that's, a lot of people are looking for how to manage as much on the front end of getting them in the ground and going and looking great as on the back end of trying to manage it while trying to get the cash crop in. So.
Yeah, I would say that's really consistent with what we hear in Wisconsin is like, it can be pretty cold and wet and rye can be not doing much in the field. And then all of a sudden it is, past where you really wanted it to be. So, and a little bit goes a long ways sometimes is what we're learning too. So, but that's a great question. I do think so. From in Wisconsin, we did finish up a study in Rock County trying to look at whether implementation of a cover crop did change the dissolved phosphorus losses from a no-till system. And there are indications that it might have reduced those dissolved losses a bit. But of course, just like was mentioned a few times, weather plays a role. And of course, in the treatment period, we just didn't get the amount of precipitation and runoff as in the control period. So, but I think there's some promising pieces to that. And then I think especially stacked together and combined with the other practices that you heard here about manure injection or incorporation where possible, and really watching those soil test values at the surface, kind of combining all those pieces together really leads to some favorable outcomes for our agricultural systems and our water quality. So with that, oh, go ahead.
I was just going to say a couple of our sites we've seen spikes, little spikes of dissolved P at termination of cover crop. But, I think for us, it was when you look at that across the entire season's load or entire year's load, it's such a small amount that there may be a little bit of a bump at that point, but it's not significant in the big picture.
Yep, that's right. Good point. Any of our other panelists have a quick thing that they wanted to add before we close up for today?
I thought there were a lot of great points brought up about these constant challenges and trade-offs that we continue to sort of run into. You just mentioned one, and Mike talked about economics and conservation and climate and, water quality and, really trying to figure out how to build these, sets of practices so that we're doing the most good that we can. And it does constantly seem like a challenge. And it was, Joshua just said, well, it was just a little blip, right? Which is great, because does that little blip mean that we should stop cover cropping? Probably not, right? But when people start to see that, it becomes this, like, are we doing more harm than good here? So, I don't know what the answer is, but I think, really addressing, the stacking practices and how we continue to do the most good that we can, probably will continue to be on the forefront.
Yeah, and I agree with Heather. I think that sometimes, the trend is, well, you need to grow cover crops, put cover crops in, and guys will try it, or farmers will try it, and but they don't really have a goal in mind. And I think we have to be very specific in what our goal is for that cover crop, and then adjust our management and selection of cover crop accordingly to do those things. But I think, and I think the other thing that happens is for us, they get grants to study cover crops. We're usually in a 3 to 4 year grant rotation. But I think that we have to look at cover crops as more of a long-term thing, because I don't think some of the things that we want to see, the positives from cover crops, are going to happen after the first 2 or 3 years. It's taken us 5 years to start seeing cotton roots getting down and being active below 6 inches. So I think that we have to keep emphasizing that you know, conservation may not pay off that first year, but don't dismiss it. Adopt it as a system and stay in it in the long term and then reevaluate it after 5 years.
Great
That
points.
doesn't fit with the short-term profitability issues that farmers have. I realize that. But at some point, I think we've been far too dismissive of some of these practices because we look at them a year or two and say, it's just not going to work.
Mm-hmm. About the journey, and it's not a specific destination, huh? Okay, let's see. We did get one more question in here. Do practices that lead to more infiltration lead to more nutrient losses in tiled fields? Oh, that's a good question.
I feel like we could do maybe a whole afternoon discussion on that.
Talk about a trade-off, right?
Yeah, I think it's a very good question. I don't have a real good answer for it. We did a project where we tried to look at some soil health metrics to kind of try to address that question. Like, if we're infiltrating more water with these practices, does that increase tile flow and correspondingly nutrient loss with that? I think it's way more complex than that, where we might be promoting more infiltration, but we're saving in other areas and maybe having some different processes going on in the soil as well. So I think it gets back to that trade-off thing that's been mentioned a number of times, where maybe in certain instances we get more infiltration, but you're probably saving in other areas as well.
It's complicated, right? And I know Eric used to talk a lot about really being aware, especially in eastern Wisconsin, where we have like heavier clay soils, being aware of those cracks that were mentioned a few times today, that when we apply injection to those fields that are really dry with those cracks and the ways that then infiltration through some of those macropores can be a challenge for tile lines as well, or for shallow bedrock or things like that. So really, like, not the easiest answer of all, but just it is very important to understand what your characteristics are in the place that you are working in, on the farms that you're working with, and kind of just try to use all of this information together as like what Lindsay mentioned, the tools in the toolbox, and be able to adapt and apply those as what works really well for your area and the farms that you're working with. One more comment that came in through the chat is about injection of liquid manure into established cover crops. That does seem to work pretty well as long as there's time to get cover crops started, a good start, and established well in the fall. So yes, thank you for that comment. And we see some similar things in Wisconsin. So anything else from any of the panelists? So there's a question that came in about potassium leaching. We farm peat soil with very high calcium and magnesium content. The CEC is very high, but they are all tied up with calcium and magnesium.
We have not looked at potassium leaching. We've only looked at it in runoff. The one unique thing about potassium, as I understand it, is that when the plant takes up potassium, potassium is free to move throughout that plant. It's never incorporated into the plant material itself, into the cell level, like nitrogen, phosphorus, sulfur, other essential elements. So that when that plant dies, that potassium is just sitting there, and it can be leached out pretty quickly out of crop residue. We're losing more than we thought, because we thought we were getting a lot of potassium fixation, but we are moving. I mean, the amount we were just shocked when we saw the amounts that we were losing.
Yeah, we have soil types that are very prone to potassium leaching as well, and farmers here struggle with that, and it really, you know, split applications, really thinking about timing and uptake are really important with potassium, especially on those soil types, because, you know, every time you take a soil test and it says you need 250 pounds of potassium, and the farmers are like, but, you know, I already did that. And, you know, so it's really about knowing the soil type, as it seemed like that individual did, and how potassium can react in those soils, and then managing for that, and understanding the soil test is telling you, you know, what that crop is going to need over time. But, you know, you have to think again about, you know, split applications to be able to feed the crops and invest your money in a way that, you know, clearly keeps you from wasting nutrients. We don't have that trouble on clay soil, though. We got plenty of potassium.
All right. Well, I think I'm going to go ahead and end it there. Thanks, Tim, for launching that poll. So we really appreciate the time you've all spent with us today. Thanks for the great questions. And we will go ahead and make sure that the recording for today for each speaker will be uploaded onto YouTube within a couple of days. And we'll make sure to send out the links for that, where you can find more information about each project or each Discovery Farms program to the same email that you registered for the webinar for. So thank you so much again for your time today, and we'll see you next time.